Hey, Mr. Roach. So we're doing number 2. We have an expanded form of an ellipse equation, and we're going to convert that into standard form using the completing the square method. So right now I have 5x squared plus 64y squared plus 30x plus 128y minus 211 equals 0. I got this expanded form of an ellipse equation off of algebra.com. You can look it up. It's a great website. And so after that, the first step that I had was adding 211 to the right side of my equation so that I was only dealing with x's and y's on the left. So what I have here is 5x squared plus 64y squared plus 30x plus 128y equals 211. After this, I rearranged the left side of my equation so that I had the x's together and the y squared and the y together. So I have 5x squared plus 30x plus 64y squared plus 128y obviously equals 211. And so what I did afterwards is I factored out the leading coefficient of both the x squared and the y squared. So I only had no leading coefficient in front of my x squared and no leading coefficient in front of my y squared. And so from this, I had 5 factored out of the original equation to have x squared plus 6x plus 64 that I factored out, leaving me with y squared plus 2y. And so after this, this is where the completing the square really comes into play. So what I did to get my 9 right here is essentially I took 6, I divided by 2 to get 3, because 6 divided by 2 equals 3. I squared that value, so I have x squared plus 6x plus 9. I did something very similar on this, on the y's. I have y squared plus 2y. I divide the 2y by 2, this middle value right here, divided by 2, so I got 1. 1 squared obviously gives me 1. So from that, I had 5, and then my x squared plus 6x plus 9 equation, plus 64, plus 64 factored out, y squared plus 2y plus 1. And this all equals 211. And I added 45 plus 64 because when I completed the square, I had to factor in the 5 over here and made sure that I multiplied 5 plus 5 by 9 because that wasn't originally in my equation. And I added that 5 times 9, which equals 45 rather, and 64 times 1, which equals 64. So I had that all on my right side. From this point onwards, it gets pretty straightforward. Obviously, we have to divide both sides by 320 to make sure that the right side of the equation equals 1, having your standard form of the ellipse equation. And so I have 5, and then obviously x plus 3 squared is my my simplified version of the original quadratic. Over 320 because I divided that by 320, and I divided this term by 320, 64 in parentheses y plus 1 squared because obviously that is my quadratic factored over 320. And so from that, I get my standard form of the ellipse equation, x plus 3 squared over 64 plus y plus 1 squared over 5 equals 1.